Hello, my name is JT, and I like to cook and talk about science. So if you like either of those things, then this is the channel for you. Today, I'm going to be making some chicken soup using mostly leftovers and talking about the fundamentals of nuclear physics, starting from the basics and working my way up. So, first things first, what is nuclear physics? Well, just by looking at the words, it seems like nuclear physics is a field of physics that focuses primarily on nuclear stuff? What is nuclear? Are we talking about bombs, energy, what? Nuclear refers to what is known as the nucleus of the atom. If you aren't familiar with the nucleus of the atom, then you might be familiar with the nucleus of the cell. And no, I'm not talking about the mitochondria, that's the powerhouse. Anyway, the word nucleus just refers to whatever is the central part of something, which may be responsible for its movement or growth. In the cell, the nucleus is like the brain, and it's responsible for orchestrating the activity of the other organelles. In the atom, the nucleus is a very small, positively charged core around which the electrons orbit. The positive charge of the nucleus is what allows electrons to remain within the atom, so it maintains the structure. Basically, nuclear physics studies stuff that happens to and with the nucleus of the atom. That means that nuclear physicists have to study things that are also on the size scale of the nucleus. So how small is that? Well, the nucleus is roughly 100,000 times smaller than the atom itself. So if you try to imagine how small an atom already is, then you have to scale that down by 100,000 times to get the size of the nucleus. Anyway, the point is that the nucleus is very, very small, even when compared to the size of the atom. And it is for this reason, among others, that we have different designations for atomic physicists and nuclear physicists. They simply study very different systems with very different properties. One helpful way to understand the difference between the atom and the nucleus is to consider chemistry. Chemistry deals with the way different elements combine to form compounds, and these bonds within the compounds are orchestrated by the electrons. The electrons are just the negatively charged particles in the atom orbiting around the nucleus. The electrons from one atom get connected to another atom, causing these atoms to be joined into a compound. Depending on the bond, these connections can be easier or harder to break. However, if we just take into account a single electron that is orbiting the nucleus, then in order to strip away the electron from that nucleus, we must apply around 10 electron volts worth of energy. Now don't let this unit get you all worked up. An electron volt is just a special way that we like to measure energy for very small things in physics. When we say EV, we just mean electron volt. If we consider this same situation, but now on the scale of the nucleus, we have to scale our size considerations down by about 100,000 times. The nucleus is made up of positively charged protons and other particles called neutrons, which have no charge. So overall, the charge of the nucleus ends up being positive. These particles are tightly packed together in this tiny nucleus, so it takes a very strong force to keep them contained. Ironically, this force is known as the strong nuclear force, because physicists are very creative. So, in order to split the nucleus or overcome this strong nuclear force, you need to apply about 10 mega electron volts, which means 10 million EVs of energy. Let's just take a moment to appreciate this. Just by going from the size scale of the atom to the size scale of the nucleus, we have changed our energy considerations from 1 EV to 10 million EVs. In case you were wondering, this is why we measure the power of nuclear weapons in kilotons of TNT. Because TNT works by chemical reactions, where we produce EVs of energy, but nuclear bombs work by nuclear reactions, which produce mega EVs. So, in short, nuclear physics is the study of the nucleus of the atom, which is made up of protons and neutrons, and how they react when things hit them or when they hit other things. In the coming episodes of this Nuclear Physics 101 series, I will discuss what happens when the nuclei of atoms interact and how nuclei can spontaneously decay to produce energy, also known as radiation. But the important thing to remember is that nuclear physics is not inherently bad or unsafe. Yes, there is a lot of energy contained within the universe, but we are all made of nuclei and atoms and chemicals and cells and tissues and organs and bodies, and we make up the biosphere that makes this planet beautiful. So it is important to know what we are made of and how we are made of it. Tune in again to hear more about what life is like for the nucleus, and as always, don't forget to season your food with your heart and season your mind with science.